All right, class. As you've heard, I'm sure by now, the school's internet, along with the area's internet, is experiencing a severe outage. So instead of having meetings, I'm going to bring you what would have been today's lesson as a short video. If you've looked online, you'll see today's module, we are starting stoichiometry. So those of you that are at this point, you will be needing your calculator today. Um, let's take a look at it here. Go to modules and scroll down to today. And we have, here's our dates, our standards, objectives, and results, and then a basic math review. Understanding and being able to use basic math is going to be very, very crucial to succeeding during this unit, as well as Unit 7 and Unit 8. So let's take a look at this little math review. It's broken into 4 sections. The first of is just talking about basic algebra. So let's go to an example. Here we go. X minus 4 divided by negative 6 equals 3. I'm going to flip over to my whiteboard and show you how to work this out. Easy whiteboard. Explain everything. Try it now. We just want a blank canvas. And we don't need their microphone. We're using our own. So, click here. What was that question again? X minus 4 divided by negative 6. Oh, no, that's not. I need, let's see here. X minus 4 divided by negative 6. And I know my handwriting is amazing right here, so equals equals 3. Now, in your math class, you should know that anytime there is a fraction, you need to get rid of that denominator. And the way to do that is to multiply both sides by the denominator. So we're going to multiply both sides by negative 6. That's supposed to be parentheses. This is going to cancel out, and we're going to get x minus 4 equals negative 6 times 3 is negative 18. All right. Now the last thing to do before we can isolate this variable is to clear off this negative 4, and we're going to do that by adding 4. So he's gone. That was a little bit big. 4. You get the idea. Negative 18 plus 4 is negative 14. So x in this situation would be negative 14. Simple algebra, manipulating variables, shouldn't be too hard. We've done this before. Now, the second section is talking about rounding. Well, rounding, we should have been exposed for even longer than algebra. It says round to 3 decimal places. 3.76811. And where's my clear button here? There it is. So 3.76811. Make sure that was right. It was. If we're going to round to 3 decimal places, it's going to be that number right there. And then do we look to the left or to the right? If you chose right, you are correct. The number to the right of the number you're rounding at, if it's 4 or less, this number stays the same. If it's 5 or greater, this number rounds up. In this case, not going to happen. So our final answer would be 3.768. Now, this may seem remedial for some of you guys, but the reason I go over this is because there's questions about it every year. So just in case, that's why we're covering this basic math quiz. All right, section 3. We're talking about scientific notation. Let's go to that section. That's nasty. We don't want to have that number. So we're going to use scientific notation to make it a lot more manageable. Now, considering my writing limitations on the whiteboard with this mouse, I'm not going to write this number out. I'm just going to work with it alongside. So, the first step in any scientific notation problem, you have to get a number between 1.0 and 9.9. So you have to move your decimal point to make a number between that range. In this case, the only place we can put it to force that, to comply with that rule is in between the 1 and the 5. So we're going to go back here and 1.57, I believe. Yes. And then a bunch of zeros. We'll get to those in just a second. The second step, we're going to round to 1 decimal place. So 1.57 is going to round up to 1.6. All right. Now, the third step, you have to count how many times you moved the decimal point. If you moved to the left, your exponent is going to be positive. If you moved to the right, your exponent is going to be negative. So let's count and see how many places we moved to get to that. The original decimal is right here. And I'm going to do this quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So go back to our board. 1.6 times 10 to the 23rd power. And we moved to the left, so our exponent is going to be positive. So our final answer for this question would be 1.6 times 10 to the 23rd. I'm sure you've done this before, but just a refresher. Now, last but not least, the fourth section is going to be on dimensional analysis. Now, that's a fancy word for changing units or unit conversions. I've given you a bunch of conversions up here to use for your conversion factors. Let's go down and find a question. Here we go. If a person weighs 125 pounds, 8 ounces, how many grams does he or she weigh? And we're going to round this to 1 decimal place. Okay. First off, we want to get from pounds to grams. I don't think we have a calculation for that up here. But we do have this, pounds to kilograms. And then we have kilograms to grams. That'll work. But wait, that ounces? What? We don't want pounds and ounces. So look up here. Let's see if we have a conversion for that. Look at that. 1 pound is 16 ounces. Let's get it all in pounds. That'll make it easier to convert. So let's go to our whiteboard. Get rid of that. And we start off with 125 pounds, 8 ounces. So first off, 8 ounces is how many pounds? So we're going to write 8 ounces. I'm sorry, let me get rid of that. 8 ounces. We're going to draw what I call a railroad track and then a railroad tie, and we're always going to put what we have over 1. Now, 1 pound is 16 ounces. We're trying to change this to pounds, so we want pounds to stay around and ounces to cancel. Anytime you want something to cancel, you want to have it on the top and the bottom. So in this case, we're going to put ounces on the bottom. So 16 ounces is 1 pound. Cancel those ounces, and then you multiply straight across. We're going to use this same technique when we get to stoichiometric calculations, so you'll get really good at it. Multiply straight across, we get 8 over 16. And that is what? 1/2 or 0.5. And then don't forget pounds. All right, first step done. It tells us we have 125 pounds, 8 ounces. So that's actually 125.5 pounds. 125.5 pounds. Railroad track, railroad tie over 1. We want those pounds to go to kilograms. It tells us in our conversion tables that 1 kilogram is 2.2 pounds. We want to keep kilograms and get rid of pounds. So kilograms going to go up top. Is 2.2 pounds. Whoops, delete that last part. Now we're going to keep going with this railroad. One more step, one more railroad tie. Now we're going to cancel out pounds because pounds went away. We want kilograms to turn into what? Grams. So 1 kilogram is 1,000 grams. Kilograms needs to go away. So it's going to go on the bottom. And then 1,000 grams on top. Cancel out those kilograms. And now you multiply everything straight across. So we're going to multiply the top and the bottom. Bottom's pretty easy. 2.2 times 1 times 1 is 2.2. Top part, 125.5 times 1,000 gives us 125,500. If I can squeeze that all on here, 125,500. And now we're going to divide that to simplify this answer by 2.2. which gives us an astronomically disgusting number of 57,045.4545. All right, last step. Our question says round to 1 decimal place. We already know how to round, so that should be easy. Round into that 4, what's a 5 do? Up or down? Up. So our final answer is going to be 57,045 point. That 4 is going to go up to a 5. And then don't forget your unit, which in this case was grams. That's a multi-step conversion. Some of them are easier than that, but I figured I would do a hard one with you. This is very similar to what we're going to be doing when we get to stoichiometry. So take note of this, and if you have any questions, be sure to ask me. Don't be afraid to ask questions during this time because this is a tough unit. It can be challenging and confusing at times, so don't be afraid to ask questions. All right. Real quickly, let's go back to that module. After you finish the math review and score at least 14, the reason you have to score 14 is because if you can't pass the math, you're going to struggle in this section. So make sure you understand how to do this math before moving on. You have your periodic table. You must use this periodic table for everything we do for stoichiometry, because I make the tests, the assignments, and the quizzes off of this table using these values. Other tables that you find online might have different values, so always use this table. And then we have our stoichiometry and the mole PowerPoint. You can run through this, look at it, save it. You'll have it to use for the entire unit. There's the hard copy notes, as always, but they are optional. And then the last thing is a short little video that talks about the basics of stoichiometry. So open this, watch the video, and answer the few questions that come in while you're doing so. Other than that, guys, pretty simple module. Make sure you understand the math. Make sure you have a calculator. And again, don't be afraid to ask questions. I'm now at my house where I have internet access, so I can answer any questions you have via email, text, remind, whatever it might be. Let me know if you have any questions, and I'll talk to you soon.